everyone. I am Bhojas, Faculty of Electromagnetics. Today we are going to discuss about basics of electromagnetics. Before we go further, I would like to introduce you about what Ekeeda is. Basically, this Ekeeda platforms provides you various types of study materials, lectures, and live doubt sessions. So you can subscribe to the Ekeeda channel, and you can also download the app. You can use the code gold11. You will get free access for 3 days. This gold11. You will get 3 days access for free for all the materials. Also, you can take subscription using the code GATE22. Okay. So using this app, you can use this to download the app and can watch it for 3 days free, all the course materials and everything. And then you can yourself evaluate how worth it is. And you can also take subscription using the GATE22. You will get, using this code, you will get 10% discount. Okay. So the best thing about Ekeeda is that it will provide you live doubt sessions. And another thing is that one subscription and unlimited unlimited access. So go through this, subscribe the channel, download the app, use code gold11, and you can, if you want to take subscription, use code this GATE22 to get 10% discount. Now coming to the topic, that basics of electromagnetics. So we will discuss this. The first question you can see, it was around this was our first question. Hope you are able to see it. What it is saying that you have to calculate the force between two charges which are separated by distance of 1 mm. So using Coulomb's law, you can simply write force is equals to K Q1 Q2 upon I square. This is R cap, this is force vector. So this is given by Coulomb's, where K is constant, given by 1 upon 4 pi epsilon. Since the medium given is air, so we will take epsilon naught equals to 8.854 multiplied by 10 raised to the power 12. Okay, SI units. The value of K is also can calculate, or this is very standard. Most of the Students know this, K 9 into 10 to the power 9. So the force will be 9 to the power 9 multiplied by charges are 1 nanocoulomb. So 10 to the power 9 multiplied by 10 to the power 9. Okay. K Q1 Q2 upon R distance is 1 mm. This is 10 to the power minus 3 square. And this will be simply equals to 9 multiplied by 10 to the power 9. This got cancel out. Okay. And this is 10 to the power minus 6. So 9 multiplied by 10 to the power minus 3 SI units, which is Newton. We have taken everything in SI units. So the final answer will be in SI units, which is Newton. So the answer A is correct. Now coming to the next question. Okay. What it is saying that there is a 3 microfarad capacitor which is being charged by constant current. This is very important. What is important is that constant current. This is very important thing, constant current. If the capacitor is charged with a resistance in series and applied a voltage, then the current will not be constant. It will be maximum. It is starting and then it will decrease slightly. So the voltage across capacitor will rise like this. And the voltage across capacitor with time, the current will decrease like this. This is current I. Okay. This blue line is current I. This is when there is a RC circuit. You have studied maybe in network analysis and circuits. Okay. Suppose if I apply here plus minus constant voltage source, in that case, how the current and voltage characteristic will be. But our question is not like that. The question is clearly mentioning that there is a constant current of 2 microampere for 6 seconds. So each of us know that what is the voltage and current relationship of the capacitor. Basically current, we know that current is equals to dq by dt. In case of capacitor, q is given by CV, capacitance, how much capacity the capacitor is having and the how much voltage we are applying. So this is the total charge capacitor have on a plate. If it's positive plate, then charge will be plus Q, and on the negative plate, the charge will be minus Q. So plus CV and minus CV. So the current will be, current I will be C dV by dt. Okay. And we are asked what is the voltage across capacitor towards the end of charging. What is saying that suppose there is a capacitor and we are applying a constant current source. This is how we draw a constant current source. This is for 6 seconds and this is for this current is 2 microampere and for 6 seconds. Okay, for 6 seconds. This information is additional. This is what our question is saying. So we will simply use this equation, integrating both the sides. What we will get, that voltage is equals to 1 upon C multiplied by I dt. So the voltage we will get from any time, you can say from time 0 to t, whatever time you are giving the current. So 1 upon C I dt. I is basically constant, so you can take it out, which is 2 microampere. Then dt, integration of dt is t, and you can put the limits of t from 0 to 6 seconds. This is how you can get the answer. Capacitance, value of the capacitance is 3 microfarad. Okay, this is 3 microfarad. Capacitance multiplied by this current, 2 into 10 raised to the power minus 6, because it was in microampere, and then the time, which is 6, so you will easily get 4 volt. Okay, extra question you can write here is that, what if he asks for extra question, you can write it as EQ. What is the energy stored? The energy stored and energy dissipated, or you can say simply that energy provided by the voltage source. These types of questions occur in network as well as they can be asked. Till the papers will not mention, but they can be asked everywhere. So what is the energy stored in capacitor? One question is this, and you can answer it like that. Energy stored is equals to half CV square, or you can also answer using Q square upon 2C, like that. Another question they can ask like that, how much energy the battery is providing or the source is providing. Okay, and the how much energy is stored and the remaining energy is being dissipated in these wires. This is capacitor, and this is charged to the desired voltage VC. This is current I. So this source will provide energy. Some energy will be stored in this capacitor, and the remaining energy will be dissipated in these wires. So these are extra questions. How much energy is stored in this capacitor? How much energy is dissipated in these wires? And how much energy is given by this source? These kind of questions can be asked, and these have been asked even in ESE and in GATE in previous years. Now coming to the next. Okay, so this is our next question. This is regarding inductor. You must remember these equations of capacitor, what we have written in the last question, and the regarding inductor we are going to write in this. So inductor is basically, VI characteristic of inductor is given by V is equals to V equals to L di by dt. Okay, this is the equation of conductor, and it is used everywhere whenever there is a inductor, provided the inductor is linear, because this relationship said that the current and this voltage are linear. How they are linear? You can say simply J omega L into I. Differentiation, you can simply write J omega in frequency domain and then Li. So they are linear, V and I are linear. So this is a linear inductor. Wherever there is a linear inductor, this equation is always useful, be it network analysis and synthesis, be it signal and system, control system, or whatever it be. This equation is always used. So this equation basically mentions there is a coil resistance of 5 ohm, and we have taken a ideal inductor resistance. We have separately written this is ideal inductor of 0.4 Henry. What they are giving? They are just giving a DC supply of 50 volt. Okay, so you can simply calculate the current in network synthesis and analysis. Yeah, network theory, you studied that at a steady state inductor behaves as a, because impedance of the inductor is ZL is equals to L omega, and when there is frequency is DC, so this will be 0, because DC is there, na, source is DC, omega is equals to 0. So the impedance of the inductor will be 0, and the current will be I will be V by Z, which will be 50 by this 5 ohm, which will be 10 ampere. Okay, now you have to just calculate the energy stored. Energy stored, how to, if you know energy stored in inductor is given by half Li square. If you don't know this, just derive this using what you know, that energy is equals to power into time. Okay, you can say simply Vi into dt, integration of that, where V is given by L di by dt. Okay, and if you integrate this, V is equals to L di by dt, dt cancel out, and limits of I will be from, suppose conductor gets the current from 0 to I naught, or whatever the current is there. So the energy stored will be half Li square. So in our question, putting the values, we will get half inductor's value is 0.4 Henry. The current value is 10 square, and you will get it 100 multiplied by 0.4, 40 divided by 2, 20 joule. Okay, this is energy stored by inductor. Capacitors and inductors, they don't dissipate energy, they just store and then release the energy. The ideal capacitor and ideal inductor, they always store the energy and then dissipate. Then they don't dissipate, they just release the energy whenever there is need. So in maybe in network and network theory, you have studied that inductor does not dissipate any energy and the capacitor does not dissipate any power. They just store it and then they release it whenever there is need, or whenever there is VI, the KVL and KCL are satisfied accordingly. So this is the correct answer. And now coming to the next question. So what it is saying that we have to calculate the whether this vector is irrotational or whether this is solenoidal or whether this is rotational or whether this is divergence-less. If you know the definition of solenoidal and divergence, then you can simply say that by that rejection, that's B and C cannot be answered. If it's a single choice, if it's a single choice, then you can simply say that these two cannot be the answer. Why? Because whenever the divergence is zero, whenever the divergence, you can say del dot of vector is zero, then it is known as divergence-less. Divergence-less, and this is also known as solenoidal nature. Solenoidal nature. Okay. So if the question is single choice, yeah, single correct. Okay. So if single correct, then both cannot be correct, na? It's a single choice or single correct. Single choice or correct. Then B and C cannot be answered because they both are correct. Okay. So B and C cannot be the answer. Single choice है तो both cannot, because both are same. B and C are same, so they cannot be the answer or the solution of this question. So they are ruled out. And you have A and D only option. So by using this method, that is, we call it rejection by option. This helps many times. Also increases probability rejection by option. This also increases probability of correction. Suppose there are 4, then 25% probability. You have rejected 2 options, then there is 50% probability. Okay. And now we will also calculate exactly that what is there. Whenever this del cross A is 0, then the vector is known as irrotational. Okay. So we will calculate whether this is 0 or this is not 0. If it's 0, then it's irrotational. If it's not 0, then it's rotational. So now coming to the definition of, we have to calculate the curl. We need not to calculate the divergence, because the divergence will give the same thing. Whether if it's solenoid, then it will be divergence-less. If it is not solenoid, then it will not be divergence-less. So it's already ruled out. So we will just calculate the curl of this vector, del cross A. In the Cartesian coordinate, it is defined by 1 divided by 1 multiplied by ax, ay, az. This is del upon del x, del upon del y, del upon del z. This is the x component of that vector, which is 3x square yz. Okay, 3x square yz. This is x cube multiplied by z. This is x cube y minus, okay, y minus 2z. Okay, so you simply need to calculate this. Calculate using that matrix. What it will be, ax multiplied by differentiation with respect to y of this will be 0, and this will be x cube. Okay, del upon del y of this, so this will be 0 and this will be x cube, minus this differentiation of this with respect to z, which will be again will be minus x cube with respect to z, because this is a partial differentiation, and in partial differentiation we take the other variables constant. Suppose we are doing the differentiation with respect to z, then we will take x and y as constant. Okay, and now other thing will be ay. If you take plus sign, then you have to do this minus this plus ay del upon del z. You can take, if you take minus ay, then you have to do del upon del x of this minus del upon del z of this. If you take plus ay, then you have to do this del upon del z, del upon del z of what is that? 3 x square yz. Okay. Minus, let's take one more parenthesis, and this will be again del upon del x. What is this? x3y minus 2z. Okay. So if I'm taking plus y, del upon del z of this and del upon del x of this. So this will be what I'm just writing value of this. So what will be the value of this? Plus ay, this is already 0. Ax plus 0 plus, with respect to z, this will be taken as constant. 3x square y, differentiation of z is 1, minus differentiation of x will be 3x square y and z will be 0. So this will be 3x square y. Okay, and then the last term is plus az multiplied by del upon del differentiation with respect to x, which will be 3x square z. I'm simply writing it here. Okay, this term I'm writing below. Okay, so this will be az differentiation of this term with respect to this. Okay, so what it will be, 3 with respect to x, 3x square, and z is taken as constant, and minus differentiation of this with respect to y, del upon del y of this. If we are doing this with respect to y, 3x square z will be taken as constant. So this will be constant, 3x square z. So every term is becoming 0. This is also 0. This is already 0. This is also 0. Okay. And this is also 0. All are 0. This is also leading to 0. This is also leading to 0. This is also 0. So the final answer will be del cross A is equals to 0. So what we know this, that del cross A, whenever it is 0, then it is irrotational. Okay, whenever that del cross A is not equals to 0, then it will be rotational. Otherwise, it's a irrotational. So this will be irrotational. Okay, so the answer will be A. Okay. Now coming to the next. What is that? Let's first clear it. This is fifth, no? Let us first clear it. Okay. This is the basically very basic equation, or you can say what everyone must know. If someone is interested in EMFT or someone is studying electromagnetic theory, then everyone must know this. This is very basic. This is a mathematical kind of thing. Laplace equation in cylindrical coordinates is given by. So I would like to tell you regarding this, that let us, if you know this, then this is direct question and direct answer. If you remember this, if you don't remember this, then just try to remember it by some logic or by some derivation. So I would like to do some basics, how it is derived. You must know that in that what we say, in Cartesian coordinate system, suppose this is x, y, this is z, coming out of the plane or out of the display. X, y, and z is like this, coming out of this, okay, out of the display, coming like this. So in that case, what is the, we say, elemental length, or elemental length, how it is described? Suppose there is a small length, coming like this, small, it is, which is contributing in every xyz, small elemental length. So it is given by dx ax dy ay plus dz az. Okay, dx is incremental distance or length in the direction of x. Okay, dy is incremental length or distance in dy, and similarly dz, this is coming out of the plane. Okay, just like this, coming out of the plane. So dz. Similarly, in that, this elemental length in cylindrical coordinate system is given by, cylindrical coordinate system is basically this. There is, we consider just a cylinder. Okay, let me just, okay, this is a cylinder, this is x, y, and we are just using it to, this is x, y, this is rectangular or Cartesian coordinate system, and this is, we are using this cylindrical coordinate system. In cylindrical coordinate system, there are three coordinates, rho, phi, or z, or some people also say it r, phi, z. Okay, so this is the radius. Okay, this is the radius rho, this is the angle phi, and the z is the height coming out of the display or coming out of the paper, whatever this is. So this is the z coordinate. So what is the distance, incremental length in arbitrarily or random direction? What it will be? In rho phi direction, it will be d rho into a rho. It must have a dimension of the length. So this is d rho is having dimension. In phi direction, this is basically phi direction. Direction, how we is to know that what is the direction. So direction is basically in a direction in which the particular coordinate system increases. So the direction of arrow will be where arrow increases. This will be the direction of arrow, because in this direction radius is increasing. So similarly, direction of phi will be in this direction, because in this direction phi is increasing. So this will be the direction of phi. Okay, so this will be a phi. How to know what will be the direction? So this is, you can easily know that in whatever direction the coordinate or the parameter is increasing, that will be the direction of that vector. Okay, in this, that when in whatever the direction x is increasing, that will be the direction of ax. So this will be the direction of ax. This will be the direction of ay, because in this direction y is increasing. Similarly, the direction of z will be coming out of the plane or coming out of the display, because in this direction z will be increasing. Okay, so in phi direction, what will be the elemental length? This elemental length, suppose I say, what will be the elemental length? I change phi by d phi, small angle, then what will be the elemental length? So this is given by rho d phi. This is the having units of length or dimensions of length. So this will be the small elemental length in this direction, a phi direction. So this is given by rho d phi multiplied by d phi. Okay, multiplied by d phi. Similarly, in z direction, it will be same. So it will be dz multiplied by az. And in the cylinder, that spherical coordinate system, it is given by there is a r, theta, and phi. Okay, phi is from 0 to pi, and this is theta is from 0 to pi, and this is 0 to 2 pi, 0 to 180, 0 to 360. Okay. So in that case, this will be in r direction, this will be dr. Similarly, you can derive it also. You just need to assume a spherical which is having a z axis coinciding with this z axis, and then you can similarly derive it also. This will be r sine theta into d theta, and another will be r sine theta into d theta into this will be in phi direction. Okay, r theta phi is there now, so this will be, you can simply calculate it. This will be in phi direction, or just first write this theta, then we will write phi. So theta, in theta direction, what it will be, r into d theta, and in phi direction it will be r sine theta into d phi multiplied by a phi. This will be multiplied by a theta. Okay, this you can simply, suppose if we assume a sphere, this is basically two-dimensional, so you have to just assume a sphere, and then theta is basically defined with respect to the z axis. Okay, so z axis, whatever the angle it's making with z axis, you can, let me simply just rewrite it. This is y. Now I'm just rearranging the vectors. This is x coming out of the plane, this is y and z, and I'm just drawing a circle. Let me draw a circle or a sphere. Basically it's a sphere. Okay, so theta is defined like that. How it is defined, this is the theta, this with respect to the z axis. This x axis is coming out of the plane. Okay, x axis coming out of the plane, y is this direction and z is in this direction. So this is the theta. So that in the direction of theta, this will be the direction of a theta. Okay, this is basically theta with respect to the z axis. So in the direction of a theta, what will be the elemental length, r d theta into a theta. Similarly, in the direction of phi, phi is basically with the angle in the plane of xy, angle made with the angle x-axis. Okay, so this will be the horizontal. Let me draw another circle. This will be basically a horizontal circle. Okay, this is like that, a horizontal circuit. Okay, this is a horizontal circuit, horizontal circle. Okay, so the phi will be directed in the perpendicular to this plane, or you can say the perpendicular to the display, going out and going in. So it's basically angle made with x-axis. So the a phi will be in the direction going into the display or going into the plane of paper. In that case, this distance we need to know what is this radius of this circle. So this will be basically, this is r. So this will be r cos theta, and this will be r sin theta. Radius of this circle will be r sin theta. R sin theta, and a small displacement with respect to x-axis is rotating like this in this plane about z-axis. So d phi. So this is the radius. That's why we are writing it r sin theta. Okay, r sin theta multiplied by d phi. This will be the elemental length, and this will be the vector a phi in the direction of phi, where phi is increasing. Okay. So by using these, I just wanted to let you know that there is a standard practice. Maybe you have gone through that, or if you have not gone through that, then you can remember the formulas just using that simple things. There is we will use this as a, this is a additional parameter. Okay, and this is again, there is no additional, there is 1 1 1 d phi dx ax, dy az, dz az, d rho a rho, d phi d phi into what is this? Let me clear it first. This is basically direction. Okay. Nobody told me this is direction of phi a phi. Okay. D phi into a phi. This is additional. Okay. In this dz az. This is similar to this. Similarly, this is dr multiplied by ar. Okay. In the direction of ar. Let me rewrite if you are, so that you can see it clearly. This is dr multiplied by ar plus r d theta a theta. Okay. This is basically z. This is for this only. Okay. You don't get confused with that why it is divided by z. Okay. So let me clear it. And z is this. Okay. This is basically z. Okay. So this is again d theta a theta. This is similar to these, but there is additional term. This is additional. Okay. Here this is additional. So we will just remember these parameters and we will just use a standard formulas for the divergence and curl and the Laplace, whatever, so that we can easily remember. So I will just come into the next and I will explain you. That how to remember these things. This is very difficult. These things only. You just need to remember a generalized coordinate system UVW, and you can replace this UVW either by X, Y, Z, or rho, phi Z cylindrical, and R, theta, and phi. This is Cartesian or rectangular coordinate system. This is cylindrical coordinate system. Some people write rho as R also, and this is spherical coordinate system. What you need to also remember that there are three parameters h1, h2, h3 corresponding to these three coordinates. Okay, x, y, z, rho, phi, z, r, theta, phi. So these are 1, 1, 1. From where these h1, h2, h3 are taken? From what we have derived in the last slides, from DL. Okay, in DL there were only 1, 1, 1 coefficient in the this dx, dy, dz, and there are 1 rho and 1, and this was 1, and this was in the phi theta direction, this was r, and in the phi direction this was r sine theta. So you just need to remember this thing. This we already remember. You need to just remember this h1, h2, h3. What is the value of h1, h2, h3 in x, y, z, in rho, phi, z, and in spherical? Now there are common, or you can say generalized formulas for what? First is del operator. Okay, suppose f is a function of UVW, where f is a function of del of UVW. Okay, so del operator. Okay, UVW may be x, y, z, it may be rho, phi, z, it may be r, theta, phi. Okay, so how it is defined? 1 upon h1 del f upon del u, 1 upon h2 del f upon del v, 1 upon h3 multiplied by del f upon del w. Okay, so you just need to remember this one formula only, and you can write the formulas for any coordinate system. In xyz coordinate system, it will be del f upon del x, because h1, h2, h3 are 1, 1, 1. So it will be del f upon del x, del f upon del b, del f upon del z. Okay, this was for del operator. Okay, gradient, you can say this is gradient or del operator. Okay, gradient. Now coming to the what next is divergence. Basically this is a vector, and this is a scalar, so this will be a vector. So the direction of it will be AU multiplied by AV, and this is AW. I forgot to write it, but this is a scalar and this is a vector. Okay, this del operator or this del is a vector operator. Differentiation in different directions, that how this scalar is varying with respect to u, with respect to v, with respect to w. So this is a vector. Now this is a vector, and then there is a, suppose there is a vector a vector. Okay, so this is basically divergence, and how it is defined is 1 upon h1 h2 h3 multiplied by del upon h2 h3 multiplied by AU upon del u plus del upon del multiplied by h1 h3 into AV multiply divided you can say simply differentiation with respect to V. Simply differentiation of this h1 h2 to AW divided by del W. Okay, this is a standard, and you can using this one equation you can just remember the three equation. What will be the divergence in xyz coordinate, what will be the divergence in rho phi z, what will be the divergence in r theta phi. Means what will be the divergence in the Cartesian or rectangular coordinate system, what will be the divergent formula for the cylindrical coordinate system, and what will be the divergence in the spherical coordinate system. That's why I'm writing this. Otherwise you have to remember three equations for this. Okay, what if you don't remember this generalized, then three equations for this. Okay, and three equations for this, and three equations for curl. Okay, three equations for del cross A vector, and three equations for Laplacian del cross F. Three equations. So there will be 12 equations. Otherwise, you have to just remember four equations: 1, 2, 3, 4. And you just need to remember this H1, H2, H3. So total 5. Otherwise, you have to remember 12. Okay. So in the next, we will do how curl is defined in this generalized coordinate system. We have just generalized the coordinate system, that there is a coordinate system having parameters u, v, w, and h1, h2 as a scaling parameters. This is scaling parameters. So we will just use this del cross A and then del square F. Okay, these two formulas I'll just write. Let me clear it. So now coming to the del cross A. Basically A vector, you just visualize that this is any vector. It may be electric field, it may be magnetic field, or it may be a velocity vector, or it may be a flow vector, whatever it may be, any generalized vector which is as like that. It is having AU means directed in U direction, which can be X, or which can be rho, or which can be R in terms of different coding. So it may be function of U, V, W. It is a function of all the parameters, but it is directed in U. Suppose this is the direction U. So it is directed in this U, but it is a function of all the three U, V, W. Let me say that suppose electric field is directed in X, but this is the function of X, Y, Z. Whenever X, Y, Z is varying, the electric field magnitude will vary, but its direction will be always in X direction, but its magnitude will vary depending on X, Y, Z. So this is a basic vector directed in AU. Okay. Similarly, you can write AV directed in AV. AV is also a function of U, V, W. It may be a function of V or W or U, or it may be a function of all the three. But we are writing in generalized form. That's why I'm writing that AV may be function of U, V, W. Any of them, two of them, or three of them directed in AV. Okay. So just let me denote it by Small AV are always in vector. I'm also putting some arrow for vector representation. AW, and this will be UV. Again, it will be function of UVW and it will be directed in AW. Okay. So representation of vector is generally from this, either this or some dot or this. This is how a vector is represented. Suppose A is written like this. This is also vector. This is also a vector. This is also a vector. Vector representation. It's a very basic thing. So del cross A, how it is defined? This is again defined as 1 upon H1 S2 S3 multiplied by H1 into AU S2 into AV. These are unit vectors in direction UVW. If it is Cartesian, then this will be AX, this will be AY, and this will be AZ, and S3 H1 S2 S3 will be 1. Okay. If the another coordinate system, then this H1 S2 will be either 1 rho 1 or 1 r sin theta. This is del upon del U. This is del upon del V. This is del upon del Z. This is H1 multiplied by AU, S2 multiplied by AV, S3 multiplied by AW. You just need to remember only one, okay, one column. You can simply write this is H1 AU, del upon del U, H1 AU. So the second row will be S2, because according to the second parameter or second coordinate, the scaling is S2 and the second parameter is directed in V. Okay. And the differentiation is with respect to the second parameter. And then again, you can correlate it. This is scaling. So in the second, scaling will be S2. And the first was directed in U, the second was directed in V. So you just need to remember these three. In the previous equation also, if you remember the first term, then you can write the other two, second and third. So you just need to remember this and this. Okay. You can write the second and third accordingly. In the divergence also, you just need to remember the first thing, 1 upon H1 S2 S3, and then the first term which was, let me write it here. What was that? 1 upon S2 S3 into AU upon del U. Okay, that was the first term. Similarly, you can write for second term, this will be V, this will be, because first term, so first is skipped or omitted H1, so there is S2 S3. In the second, this will be, second will be omitted or second will be avoided. Second को छोड़ देंगे, तो in the second this will be H1 and S3 and this will be V. So you can use the logic to remember also. And now coming to the this final del square F, or you can say del square V. This is a scalar function. This is also a scalar function, or whatever scalar function is there, del square phi, or you can also say del square phi, del square psi, whatever you want to. This is basically any scalar function F. Okay. So in this case, this is defined as del divergence of gradient. Divergence of gradient. Okay. So there we will use the two things. First, we will use that definition of gradient, then we will use the definition of divergence. Okay. So now coming to the, suppose I'm using this first I'm using this divergence thing. So divergence is defined by 1 upon H1 S2 and S3. Okay, multiplied by del upon del U multiplied by H2 S3 into what is the vector in the U direction. And the del V, we already know that del V, what is this? Del V is 1 upon H1 into del V upon del U into AU. Okay, multiplied by. So this is how this is going on. Okay, 1 upon S2 del V upon del V directed in AB. So this is basically that vector AU. In divergence, we put here AU. and this is basically AU. Okay, the magnitude which is directed in AU. So this is basically AU. So we will just put it here, 1 upon H1 goes 1 upon H1 into del V upon del U. Okay. You just need to remember first thing. From second onwards, you can simply write del upon del V correspondingly the second parameters or second coordinate, and what it will be, we will just omit or avoid the second. So we will write just H1 multiplied by H3, because in first we just avoided the first or the omitted the first. So the in second H1 H3, second is omitted, second will come below, and then it will be del V multiplied by, let me clear it, del V upon V. Okay, this is different, the scalar function, and this is the parameter. That's why I've taken a small, otherwise you will get confused that what is this del V and del V. This is a scalar function, and this V is basically a small v, which is parameter or coordinate. Okay, or you can simply write it f. If you want to avoid the confusion, you can just del f upon del u, but del v upon del f upon del v. But we are given since in v, so we are writing it. And the third term will also be similar. And now using this, we will write our answer to that question using this. Okay. So I'm just clearing this above thing, and then we will write our final answer. This is basically derivation. I could have simply provided the final answer, but I thought that I should give some basics how to remember these 11-12 formulas, or how they are, how they are derived. You can just go through the theory, the electromagnetics by Sadiku or the Heath and William. In that case, you will know how these are derived and how to remember also. You cannot remember so many things because there are 8 to 10 subjects in engineering, 10-12 subjects, and then so much material. So we will write using this. So in case of cylindrical, in case of cylindrical, watch are H1, S2, S3 are 1, rho and 1. Okay. And what are the parameters? Rho, phi and z. So we will just use it, 1 upon rho multiplication of that H1, S2, S3. This is basically 1 upon rho. Now coming to the next, del upon what is the first parameter, del rho, and what is S2 and S3. S2 and S3, this is basically rho. Okay, multiplication of these two rho. And what is H1? H1 is basically 1. And then what is the our function V? Maybe it's a voltage function or any other V, any scalar function, del V divided by del rho, because U is first coordinate or first parameter, which is rho. Okay. So we will first differentiate with, then we will multiply it by rho, then we will again differentiate with this. Okay. Now the second term will be del upon what is the second parameter? Phi, del upon del phi. This V is basically parameter or coordinate. This is not equals to that this V. Okay. This is a smaller V, small v. This is a parameter or coordinate. This is a function. So don't get confused with these two. Okay. There will be so many confusion that V is voltage. Okay. You just remember that V sometimes is voltage, V sometimes is velocity, V sometimes is any generalized coordinate system. Okay, generalized coordinate system. You must know what is the difference. And V sometimes is, let me write here one, V sometimes is velocity, voltage, general coordinate, or V is also volume. Many times it's a volume also. So don't get confused with V. You just, what is this V? Remember, sometimes they write it by small or large, and then they try to differentiate. So this is del upon del phi. This is second coordinate system. What is the H1 and S3? They are 1, 1, 1. And what is the S2? S2 is basically 1 upon rho. This is, they are 1, 1, 1. And what is the our this function, scalar function v, and differentiation with respect to v, that is phi, small v. And the third term we will simply write there del upon del z, and again multiplication. Third we will omit. So H1 and S2, multiplication of H1 and S2 is rho. And the third, this is our scalar function v, and divided by, this is H1 and H1 multiplied by S2, and there will be S3 will be below. So S3 is already 1, and this will be del Z. So this will be the our equation in cylindrical coordinate system. Okay. What you can do here, we are doing differentiation with respect to phi. So we can take this row outside. So I'm writing final equation. Okay. I'm taking this row inside, 1 upon rho. Okay. I cannot take this row outside because the differentiation is with respect to rho, and rho is not constant. So this will be the final equation, del upon del rho. This is rho, and to del v upon del rho. Okay. Let me write in different color so that you don't get confused. You can easily see it. And then again, I'm taking this inside. So this will be 1 upon rho. And this we can take out because the differentiation is with respect to phi, and this is a partial differentiation. So the other parameters or other coordinates will be taken constant. So this 1 upon rho is constant. I can take it out. So it will become 1 upon rho square. 1 upon rho is this, and 1 upon rho is this. So del upon del phi. And this is again del, okay, double, you can say this is basically double integration, del v upon del phi. So it will simply convert to del square v upon del phi square. Okay. And now the next term is 1 upon rho. I'm taking from here. And again, I can take it out because this is a constant, because I'm doing partial differentiation with respect to z, and this is rho. So rho will be taken as constant. When I'm doing differentiation, partial differentiation with respect to z, I will take rho and phi, other the two parameters, as constant. So I'm taking it constant, and I will take it outside of this differentiation, and this 1 upon rho and 1 upon rho will cancel out. Rho upon rho will cancel out, and the final answer will be del upon del z. Let me rewrite it, del upon del z multiplied by del v upon del z. Okay. So from that question, you can simply determine our solution. 1 upon rho, del upon del rho, rho v del v, 1 upon rho square, del upon del phi. This will be simply double differentiation, del square v upon del phi square, and this will cancel out. Okay. Let me cancel it. This will cancel out. Okay. And then this will be again double differentiation, del square v upon del z square. Okay. So coming to our question, what will be the answer? This will be our answer. Okay. You can just match 1 upon rho, 1 upon rho, del rho upon del rho, rho upon del v upon del rho, 1 plus rho square, del phi upon del phi square, del v upon, this will be double differentiation. Okay. So this is equals to this. You getting it? This is, let me take this will be equals to this. Okay. And this will be double differentiation, del square v upon del z square, which is equals to 0. So this will be the Laplace equation in cylindrical coordinate system. By using the generalized equation in any coordinate system, you can simply remember all the 12 equations. You just need to remember 4 5 equations, and you can just derive 12 equations. It's a hardly, if you practice, then it's a matter of hardly 1 minute or 30 seconds, if you practice properly, in that case only. So this will be the correct answer. Okay. So it was asked in cylindrical coordinate system, and you can just take extra question that just try to remember the generalized equation and then just try to derive all the 4 equations, del of f gradient, which is gradient, and another is, this is a scalar function, and the final answer will be vector. Gradient is operated always on scalar function, and the final will be vector. And this is divergence, okay, del dot a. This is vector, this is also vector, and the final answer is scalar. This is known as divergence. And then there is a curl circulation, which is also known as a circulation, del cross a vector. Del is basically operator, like there is plus, addition, minus, subtraction, addition. So this is also a mathematical operator which has advanced many things, many types of integration, accumulation, and so many things. So this is gradient, divergence, this is curl, and the another is Laplace. Okay, which is also again operated on a scalar, del square f. It may be any scalar function or v or phi or any scalar function. So there will be 12 equation. You just first remember 4 generalized equation. Try to recall and remember 4 generalized equation, and then try to derive these equations. 3 for this, okay, Cartesian or rectangular, then this is cylindrical, then this is spherical, okay, and this 3, 3, then 12. In that case, you can practice it, and then it will be easy for you to remember. Now coming to the next question. This answer is A, and we will simply go to the next question. Okay. This is again related to the same what we have discussed so far. That's why I've derived all these things. So there are so many questions. This divergence, curl, and the gradient, Laplace, it will be used throughout the electromagnetics. It will be used in electrostatics. It will be used in magnetostatics. It will be used in Maxwell equations. Everywhere it will be used. That's why I try to discuss in a elaborative way or some kind of derivative way. And for proper derivation of all the parameters, you can go through any standard book. Now coming to this is again is a solution of Laplace equation. What will be the value of it? The Laplace equation. This is basically del square. Let me del square v equals to 0. This is Laplace equation. Okay, and from where it comes? This comes from this minus q upon epsilon, or you can say rho v. So charge free region is there, na? In that case, you can say q upon epsilon. This is what this is known as Poisson equation. Okay, Poisson equations. So if the region is charge free, then q will be 0, and this will be the Laplace equation. Okay. So we will just use it to find the answer of this. You can just calculate and let me know if you are able to find it. Okay. Just giving a 1 minute time to you. If any of you are live, you can just solve it. You can try to solve it. Derived everything, so it's a very easy. And the best thing in this is that this is a spherical, not a spherical or cylindrical coordinate system. This is basically Cartesian or rectangular coordinate system. So you can easily derive it, and it's very easy to solve it. Okay. So this is basically, if you remember, this is basically rho V. Okay. The charge density, not the exact charge. This is charge density rho V. You can simply write it QD, or you can let me write it in different form, which is also, you can just write it rho V. That will be better, otherwise you will be confused. Charge density. Okay. So when there is no charge, so this will be the Laplace equation, and in the Cartesian coordinate system, it's very easy because H1, H2, H3 are all 1, 1, 1. So there are double differentiation in every direction, or you can say every parameters. So it will be simply del square V upon del X square plus del square V upon del Y square plus del square V upon del Z square. Okay. You just need to double differentiate and put it equals to 0, and you will get the answer. Okay. So now try and let me know the answer if you can. Otherwise, I will solve it. This is basically sine hyperbolic x, and this is cos simple trigonometry. This is hyperbolic function, and this is simple trigonometric. This is exponential. So if we solve, this is differentiation with respect to the x square. Okay. Double differentiation, sine differentiation cos hyperbolic, and then again differentiation of cos hyperbolic x will be sine hyperbolic x. Okay. So this will be sine hyperbolic x cos ky e power pz. Okay. For first term, and with respect to the y, the differentiation of cos is equals to minus sine, and sine is equals to cos. This k square will come out, so this will be k square, and then again it will become cos ky, and everything will be same because sine hyperbolic x, this will be treated as constant. The other variables, because we are doing the partial differentiation, sine hyperbolic x and e की power pz, these will be treated as constant. Okay. And what will be the next? The next will be with differentiation with respect to the z, and in that case you can simply write with respect to the z, these will be treated as constant, sine hyperbolic x multiplied by cos ky. Okay. And this will be treated as constant because we are doing partial differentiation with respect to the z, and you have to do the differentiation 2 times. So differentiation of e की power x will be that e की power x, it will come outside first, that p e की power pz, and then again if you differentiate 2 times, then this will become p square, and you have to put it is equals to 0. So you can just cancel out the same terms. Okay. And then you will get e की power pz is in the always there in all the 3 terms. So we will just divide it to 0, and then we will get it. Cos ky is also there in all the 3 terms, and sine hyperbolic is also there in 3 terms. So what we will get is 1 minus k square plus p square. Okay. is equals to 0. From this, what we will get is this, and you will simply get it. What is the value of k? Will be the value of k 1 plus p square root of 1 plus p square. Okay, so the answer will be B. Okay, this will be the answer. Now coming to the next, let me clear it, and then this is our 7th question. This is again what I told in earlier question also. This is basically you have to determine the value of phi at different points. Okay, you have been given with the 2 coordinate systems, x, y, z. One is this x, y, and you need not to worry about z, because by using that cross product x, y, then z will be in this direction coming out of that plane. Okay, from this point coming out of the plane. Okay, from this point, this will be the z direction coming out from this point, out of the plane of the paper or out of the plane of display. Okay, and you have to determine that this phi in terms of x, y, and z. Okay, so there is again one which is very, illustrative or understating or visualizing type of method, and the other is the standard method which we will derive later. First we will just try to find out that what will be this a phi components at different points A, B, C, and D. I've told you that direction of a phi is, you just first need to know that what is the direction of a phi. This is the direction in which a phi increases. Small incremental change. Small incremental change. It must increase, not decrease. Okay, small incremental change in phi. ए फाइव की डायरेक्शन वो डायरेक्शन होती है जिस डायरेक्शन में फाई थोड़ा इंक्रीज कर रहा है. सो फाई की जो डेफिनेशन होती है वो ये होती है कि ये एक्स एक्सिस के रेस्पेक्ट में मेजर करा जाता है ऐसे, विथ रेस्पेक्ट टू एक्स एक्सिस, दिस इज फाई. सो फाई इंक्रीज करेगा इस डायरेक्शन में, जैसे यहाँ होगा तो फाई थोड़ा और इंक्रीज करेगा, फाई विल इंक्रीज. सो द डायरेक्शन ऑफ ए फाई विल बी डायरेक्शन इन विच फाई इंक्रीजेस. So at this point, suppose this is the point, so at this point this will be the direction of a phi. Okay, this will be the direction of a phi, this direction. Okay, let me draw again here, this will be the direction of a phi. Okay, and here the direction of a phi will be this, because the a phi will increase when I move in this direction. So here the direction of a phi will be this. Okay, perpendicular to this radius. Here the direction of a phi will be this, because here phi is 90 and phi will increase when I will move in this direction. Okay, so small incremental change in phi is the direction of a phi. So here direction of phi will be this. Okay, because here phi is suppose 135, then it will increase when I will move slightly in this direction. If I move in this direction, then phi will not increase. Okay, that's why you can say small incremental change in phi. You can say maximum change in phi, direction in which there is a maximum change in phi. That will be the direction of a phi, unit vector in phi direction. Okay, and the here direction of a phi will be this. Okay, so now you just have to break up this vector into two different vectors, x and y only. This is now this question has become very simple. For a, this is the a point, and you have to just break up in x and y direction. This is x direction and this is y direction. It is already in x direction and there is no component of this a phi. A phi is basically a unit vector. Okay, this is a unit vector in phi direction. Okay, unit vector in phi direction. Unit vector in phi direction. And phi, what is the phi direction? Direction in which phi increases. Okay, direction in which phi increases maximum. So a phi is unit vector in phi direction, and phi direction is the direction in which phi increases with maximum amount. Okay, so this in this direction phi will not increase, in this direction phi will increase maximum. Suppose I move 2 meter this, the phi will not increase. If I move 2 meter in this direction, the phi will increase maximum. If I move 2 meter in this direction, then also phi will increase, but with some less amount. So the direction of phi is the where the coordinate or the parameter will increase in maximum amount. Okay, so you just need to break up this. So at point A, okay, at point A, what will be the breakdown, or you can say bifurcation of this vector a phi. This is a phi. So up you have to just break it down into two components, x and y. It's already in minus ax direction. Okay, so a phi is equals to minus ax, unit vector in minus x direction. Okay, and there is no component of this in y direction because the angle is 90 degree, and you just need to break it down, and you have to just break it in component. You must know the component of a vector, how to get component of a vector. Suppose this is a vector a, this is vector a, then you must know this is theta, then in this direction this will be a cos theta. Okay, a cos theta, this vector will be a cos theta, and this will be a sin theta. Okay, you must know how to get component of a vector in any desired direction, whatever the angle it makes, and the cos theta with that angle. So this will be 0 in y direction. So a phi will be this for point B. Okay, for point A phi is equals to minus ax. Okay, for point B, you just need to break it into two components, this component and this component. Okay, so this is making angle 45 degree. Okay, this is 45. So this will also be, this is 90, and this is also be 45 because this angle will be 180 degree now. This is 90. Okay, basic trigonometry, this is 90 and this is 45. So this will be also 45, and you can just break it down here. Suppose I put an equation, this is 90, so this is will again be 45. Similarly, this will be 90, so this will be 45. And you can also use that parallel theorem, or you can alternate angles. This is 45, then this will be also 45. So these angles are 45. Okay, so you just need to component it. So this component will be a phi into cos 45. Okay, and this will also be a phi into sin 45. Okay, this. So at B, a phi will be, this is minus ax direction. Okay, minus ax by root 2, 45 is root 2, and minus ay. Both are in minus direction. This component is also in ax direction. This is also in minus ay direction, and cos 45 is also 1 upon root 2. This is also 1 upon root 2. So this is minus ay upon root 2. Okay, and at C, you can simply again break up it. This will be first component, and this will be the another component. Again, the angle will be 45 degree. These two angles will be 45, 45. So this component breakdown, the breakdown of this vector in the x direction and y direction will be like, this will be in positive direction, ax by root 2, because angle is 45 degree. And again, this is in positive x direction, this is in positive y direction. So this will again be ay by root 2. Okay. And for D, it will be simply AY. So for D, simply it will be AY. Okay. For C, we have just calculated it. That for C, it will be plus AX plus A by root 2. Okay. This. And for B, it will be both negative. Okay. Where there are both negative in fifth. They are both negative now. So let me just use for B, it will be both negative. And for A simply it's minus AX. Okay. So it will be 3. So it will be 3. So what will be the answer regarding A 3, and for B 5, and then 4 and 2. So D will be the answer. 3, then 5, then 4, and then 2. So D will be the answer. Okay. If you want to note down, note it down. Otherwise, I will clear it and we will go to the next question. Okay. I would also like to tell you the second method of this question, how to solve it. So let's first discuss that. For second question, you just need to know what are few things, few basic things related. You must know the point transformation. I think whoever watching it, they must know the point transformation between these three coordinate system. Point transformation. Okay. And they also must know the vector transformation. Vector transformation. What it means that you must be able to know, you must be able to do transfer from XYZ coordinates. Suppose you are given, then you must be able to transform it into the rho phi z. Okay. And then from this to spherical, and directly spherical to that r, theta, and phi. Okay. You must be also parallelly must be equals to transfer from these two also. Okay. If you are given XYZ, then you must be able to calculate or evaluate or solve for r theta phi. And if you are given r theta phi, then you must know what are the XYZ. And similarly, vector transformation is also there. What it means that if you are given a vector which is given by this, suppose this is AX vector, okay, directed in AX kf plus AY, which is directed in AY plus AZ, which is directed in AZ. Then you must be able to know, if you are asked to calculate that a vector, what will be this arrow directed in rho, what will be the a phi directed in phi, okay, and what will be the rho phi z, what will be the z az k. Okay. If you are given this, a vector is given which is having ax component in x direction, ay component in y direction, az component in z direction, then you are asked to calculate, you have to calculate a vector in rho phi z, that is cylindrical coordinate system. So what will be the value of a rho, a phi, and a z? You must know this also. If you don't know, then please go through the theory book or theory lectures provided by Ekeeda. Then you will be able to do it. I'm just giving a very basic derivation of this one. Okay. How to do vector transformation. Okay. Point transformation you can easily understand. Okay. So I'm just clearing it and then I will do just that. Suppose We have this coordinate system, cylindrical coordinate system, and the Cartesian or rectangular coordinate system. Okay, this is Z coming out of this. You must also know this this convention. This is coming out. Okay, coming out, coming out. And this is going in, going in the display or going in the plane of the paper. Okay, if you don't able to remember it, then you just simply need to, what you have to do, you just need to remember it using arrow. Arrow is having two heads. Okay, this is arrow front head, means arrow is coming out, and this is arrow's back end, means arrow will go inside the plane. Okay, this is a convention of, okay, vectors coming in or out. Sometimes they just represent. So this will be the Z coming out of the plane, and there is a, we've also taken that cylindrical. Okay, this is cylinder, or let me draw it just in bigger form. Okay, so I'm drawing it a little bit bigger. I'm taking vector. I'm taking vectors in what direction? What we have to calculate in that question? We have to calculate, we are given the unit vectors in one coordinate systems, and we have to calculate the parameters in other coordinate system. We are given in the cylindrical coordinate system. A vector is given in cylindrical coordinate system. What is our question? What our question is saying that phi is given. Okay, you are given phi, and you have to calculate its component in ax, ay, and az direction. Okay, simply vector is given in cylindrical coordinate system, and you have to calculate that vector. What will be the value of that vector in cylindrical, rectangular coordinate system or Cartesian coordinate system. So we will take a vector. Okay, we will take a vector in cylindrical coordinate system, and then we will try to convert it to a rectangular or Cartesian coordinate system. First, there are three vectors in that cylindrical coordinate system. This is arrow. Okay, and this is phi. Component of this will be, this is phi now. So component, this will be, one component will be in this direction. This will be arrow cos phi. Okay, and this component will be arrow sin phi. Okay, and now I break up this vector into two components, x and y, and this will not have any component in z because it is having angle 90 degree. So arrow cos 90 will be 0. So this will not contribute in a z vector. Okay, to a vector component in z direction. Okay, now I will take a vector in phi direction. Suppose I'm taking this vector. Okay, phi direction. This is a phi. This is a phi. I will break up it into two vectors. Okay, so I will simply break up it in this vector and in this. Since this angle is phi, so this angle is also phi, and this is 90 degree with radius. So this will be 90 minus phi, and this will be phi. Hope you are able to get it. This is phi, so this is alternate angle. This will be phi, and this angle is 90 because radius is making angle with tangent is 90. So this will be 90 minus phi, and this will again be phi because these two are perpendicular. So this will be again phi. So this component, I'm writing it here. This component will be a phi cos phi. Okay, and it will be in ay direction. Okay, and this component I'm writing it here. Okay, this component I'm writing it here. This will be a phi sin phi, a phi sin phi, and it will be in minus ay direction. Okay, minus ax direction, sorry, it will be in minus ax direction. This is minus x direction, this is plus ay direction. So what I have done is this, that this arrow is equals to arrow cos phi. I will write it again with different color in final. Now I have break up this a phi in two direction, x, y, and x and y, and it will be having zero component z direction because z is coming out of the plane and the a phi is having 90-degree angle with az. So the component of this vector in z direction will be zero because a phi cos 90 is zero. So I have taken the component of this in xyz, taken a component of this in xyz. In z they are zero, and in x and y they are given by this, this, and this, and this. Now what I will do, that the component of az along az, it will be same because the z axis is same in both the coordinate system. So the component of az along z, az will be same, and along ax and ay they will be zero because az is having angle 90-degree with ax and ay. So az cos 90 will be zero, and az cos 90 will be zero. Okay, and az sin 90 will be zero. Okay, az sin 90 is also zero. So the component of az along x and y will be zero. Now what I can write simply, that let me write in different color, that this arrow vector is equals to arrow cos phi multiplied by ax cap in the direction of this unit vector x cap. Okay, and the one component is along ay. So what I will write, arrow multiplied by sin phi in the direction of ay. Now I will write a phi. Okay, component of a phi in the x direction, this is a phi, in the x direction this is minus a phi sin phi ax cap, okay, in the direction of x vector, and this other component is this, which is given by a phi cos phi in the direction of a phi cos phi in the direction of ay. Okay, and breakup of this az, you can simply say that az is given by in the x it will be zero because there will be angle of 90-degree, so it will be zero in 0 multiplied by ax cap, and it will be 0 multiplied by ay cap, and it will be 1 multiplied by az cap. Okay, so it will be 1 multiplied by az cap, and these other things will be 0 multiplied by az cap because they will not have any component along z, because this arrow is having angle 90-degree because arrow is in xy plane and z is with 90-degree with respect to xy plane. Similarly, a phi is also in xy plane and the az is at 90-degree with respect to xy plane. So this will be 0. So from this you can just derive a matrix. What will be the value of a rho phi in z? Okay. So basically you can say ax will be a rho. If I want to calculate the ax component, from A phi Z, AX component will be, what will be the AX component? AX component will be simply, AX vector component will be A rho cos phi, okay, plus, you can say this is actually minus, so minus A phi sin phi, minus A phi sin phi plus 0. Similarly, you can write AY cap. What will be the component of AY cap? These will be the component of AY cap. Okay. You are given a row, you are given a row, a phi and a z. You are given the vector in cylindrical coordinate system, rho, phi and z. You are given a row, you are given a phi and a z. And you have to convert it into the xyz, Cartesian or rectangular. That's why I'm taking what will be the ax for a row, a phi and a z. Similarly, this will be, what this will be, a row sin phi, okay, and this will be a plus a phi cos phi plus 0 to az, okay, plus 0 into az, and az will be equals to az. Other terms will be 0. So you can just write a matrix. I'm just clearing it and writing a matrix, okay. So you will be able to see it from here, that how they are derived. So what will be the ax? You can simply say that ax, ay and az will be equals to arrow I'm taking out. There are zeros, 2 zeros, okay, which are multiplied by arrow plus 0 into a phi, okay. So what is ax? Ax is basically multiplied by cos phi, okay. This is ax, row by column, if you multiply it, sin phi, and this will be, you have to just multiply it. There is 0, 0, 1, and this will be a row by column, okay, row into a phi multiplied by az. Just making the different representation of this equation, okay, these three equations. The equations can always be represented by a matrix of 3 cross 3, okay. So to determine ax, you have to multiply this row by column, a row multiplied by cos phi, a phi multiplied by minus sin phi, okay, and then you have to multiply this minus sin phi, this a row, again this is sin phi, and this is cos phi, and this is 0, 0 and 1. And if you want the inverse of this, suppose you are given with ax, ay, az, and you have to calculate a row, a phi, az, then you just need to take the inverse of this matrix, because you will just divide it by this, and you have to take the inverse of this matrix and multiply it by here, and then simply you will get a row, a phi, az. If you are given this, then just take the inverse of this matrix and multiply by it, and you will get a row and a phi and az. In our question, we are given a phi, and we have to multiply it to get ax and ay, okay. So simply from here also you can get what will be the contribution of a phi along ax, ay and az. Just solve, you will get the same answer, okay. I'm just clearing it. Coming to the next. Okay. Now this we will study, or you will study if you have gone through the lectures of magnetostatics, then maybe you know this. I'm just letting you know. If you have not gone through those lectures, then you will get it when you will go through the study materials or the lectures which are related to these topics. There is, in electrostat and magnetostats, there is some correlation is there. So let me just, this is suppose electrostatics and this is magnetostatics. There is EMF and there is MMF. Okay. And in this we have current, in this we have flux. Okay, flux linkage. In this we have resistance, or you can say in this we have reluctance, which is sometimes symbol is sometimes S. Okay, this is resistance, this is reluctance, and this we have other parameters, conductivity, sigma. In this we have permeability mu. Okay, this is sigma and this is, let me simply write mu. Okay, in this resistance is given by R rho L upon A. Here also just remember, this rho is sometimes resistivity, this rho is sometimes volume density of charge, rho V. Okay, this rho is also a coordinate or a parameter in cylindrical coordinate system. So you must know what the meaning of the symbol is there. There are different kinds of symbol used for the, same symbol is used for different kinds of parameters or different physical quantities. This is resistance, and reluctance is given similarly like this, L upon mu A. This is 1 upon sigma, no? L upon sigma A. Okay. So you can simply this EMF, there is electromotive force, and in magnetostats it's known as magnetomotive force. Okay. And this is the current flows there, and there is a flux linkage is there, magnetic flux. They are correspondent or relevant, or you can correlate directly. There is a resistance in electrostats and there is a reluctance in magnetostats. Conductivity, there is a permeability. So what will be this? Suppose MMF will be related to EMF. Magnetic flux will be related to the electric current. Reluctance will be related to the resistance or correlated with resistance. And this will be the equivalent of the conductivity. Okay. So what will be the answer? You can say A is for 3 and B is for 2. So the C will be the answer. Okay. You will also study various laws. There is a, Coulomb's law in electrostats. There is a Ampere's law, or the first, what there is a Gauss law. Okay, another law, there is Gauss law, there is Ampere's law, Faraday's law. Okay. Here also you will learn Lorentz force. Lorentz is basically related to both the electrostat and magnostat, because the force is given by Q into QV cross B, Lorentz force. Okay. Another correlation you will study whenever you will go through the content, but if you already know, it's very good. Now I'm clearing it and coming to the next. This is again, that's why I try to derive, in that case we have derived 4 things now. Del of F, gradient of a scalar, divergence of a vector, del dot A vector. Okay. And then the curl, Then there is a curl of vector. A is any vector. It may be electric field, magnetic field, velocity vector, or any vector, any physical vector. Gradient, divergence, curl, and then there is a Laplace, or you can say Poisson. Laplace or Poisson equation, okay, which is again operated on del square of scalar, which is equals to divergence plus gradient, divergent of gradient of scalar, divergence of gradient of scalar, okay. That's why I tried to generalize these four formulas using a generalized, coordinate system U, V, W with scaling H1, S2, and S3, so that you just need to remember 4 or 5 equations and you will be able to drive all the 10-12 equations within a minute or two, okay. So again, this is a vector, and this is, by fortune, or you are lucky that this is again in the Cartesian coordinate system, which is a rectangular coordinate system. So there is H1, S2, S3 are 1, and you can easily remember these formulas for this Cartesian coordinate system, okay. So we will just do it. For irrotational, when it will be rotational, when del cross A will be 0, then it will be rotational. And when del cross A vector, so we have to calculate it whether it is 0 or not, and it will be solenoidal when this is divergent is equals to 0, okay. So first we will calculate the curl of this, and we know 1 upon H1, S2, S3, they are all 1, and H1, S2, S3 here also 1, and AB is given by AX, this is given by AY, and this is AZ, okay. They are 1, H1, S2, S3 are 1. This is del upon del U means del X, del upon del V matlab second coordinate or second parameter, which is Y, and del upon del Z, and this is again AX, okay, AY, and AZ. So we will simply calculate it by putting the values AX, AY, and AZ. This is del upon del X, del upon del Y, del upon del Z, okay. What is AX? This is AX, okay, Y into Z, which is directed in component which is directed in X direction, okay, and component which is directed in Y direction, AY, this is ZX, and this is XY, okay. And you just need to solve it. What will be AX? AX will be simply differentiation of this with respect to Y, so X will be constant, so X differentiation of Y is 1, and then differentiation of this with respect to Z, X will be the constant, X will be treated as constant, differentiation of Z will be 1, so it will be again X plus, or you can take minus, whatever convention here you use. If I'm using plus, then I will do this del upon del Z into this minus this. If I'm using minus, then I will use this del upon del X on of this and del upon del Z of this, okay. So I'm using plus convention here, so I will just do del upon del Z of this. Y will be treated as constant, and differentiation of Z will be 1, so Y, and then again differentiation of this with respect to X, Y will be treated as constant, so differentiation of X will be 1, so this will be Y, and then coming to the Z plus AZ. In case of AZ, this is this, so I will just do differentiation of this with respect to the X, so Z will be come out being a constant because this is a partial differentiation, and differentiation with respect to Y, so Z will come out, and differentiation of Y will be 1, so these are 0, so the final will be 0, since del cross A, this is, what is this, del cross A vector is 0, so it's irrotational, okay. What is this? This is correct, irrotational. Now we will calculate whether that this is solenoidal or not. For that, we have to calculate the divergence of that vector. Okay. Again, we will use the divergence formula. Let me clear it. So this is irrotational. We have calculated. Now we will calculate del of a vector divergence. I am again using the generalized formula 1 upon h1 s2 s3. They are 1 1 1. Okay. And now del upon del u. What is u? Here x, because the first coordinate or first parameter is x. Del upon del x multiplied by s2 s3. They are 1. Okay. So I'm not taking that 1. I'm just not writing that 1. I'll simply write what is next. Del upon ax upon del x. Okay. Similarly, second term will be del. This is basically a double differentiation. So I'm just writing the one step advance. So the second step will be del square ay upon del y square plus del square az upon del z square. Okay. Okay. In this, square is pronounced here on del and here it is pronounced on z, because this is del z square, differentiation twice with respect to the z. So del square az upon del z square, not del square az upon del square z. Okay, this is not correct. Del square az upon del z square. This is correct. So now we will do the differentiation, and you will get that double differentiation with respect to the x of this term ax. Okay, with respect to the x, because yz will be treated as constant, yz being the partial derivative, so this will be the constant, and there is no terms of x, so the differentiation will be 0. Similarly, differentiation with respect to the y square, double differentiation with respect to the y of this term, this will be again 0, because there is no y term and x and z are treated as constant. X and z will be constant. Similarly, here double differentiation with respect to the z square of what? Az. This is az. With respect to the z square, there is no z term and xy will be constant. So again, differentiation, double differentiation will be 0. So this will again be 0. This will be again be 0. Del dot a vector, which is divergence, will be 0. So this will be solenoidal also. So answer will be both A and B. Okay. Any doubt? Now coming to the next, clearing it. This is again same. So most of the questions are based on those 3-4 equations. The basics of the electromagnetics, all the questions are based on these: del f gradient, del dot a divergence, del cross a curl, and del square a Laplace. Okay. So again, this question is already same. We have already done the derivation or how to remember these equations, and you are lucky that this is again in Cartesian or rectangular coordinate systems where scaling parameters h1, s2, and s3 are 1, 1, 1. So the equation is very simple. So del square v will be 0, and del square v, we know that del square v is given by in the, because h1, s2, s3 are 1, so there will be double differentiation of v del square v upon del x square upon del x square plus del square v upon del y square plus del square v upon del z square. Okay, so double differentiation with respect to the x square. What will be the double differentiation? First differentiation will be 2xyz, and then the next differentiation will be 2yz. Okay, and differentiation of this with respect to the x will be 0, because a is constant and y and z are or Z will be constant with respect to the X. So this will differentiation of this with respect to this will be 0. Okay. So now calculating this differentiation of V this with respect to the Y, double differentiation with respect to the Y, first differentiation will be X square Z and the second differentiation will be 0 because there is no term of Y and X square Z will be treated as constant. So differentiation of this will be 0 with respect to the Y. Now coming to this differentiation of this with respect to the Y, first differentiation will be 3a y square Z. Okay, first differentiation will be 3a and I'm 3a y square Z. Okay, 3a y square Z, and second differentiation we will do. Okay, and now coming to this double differentiation with respect to Z will be 0 because there is first order of Z, no? So in the first differentiation this Z will vanish, X square Y will come, and then in second differentiation this will become 0. Similarly here, if we do first differentiation this will be ay cube, and in the second differentiation this will become 0. So this will be the 0. This will come to 0. Okay, this will be 0 here, and this will also come here, and this is the differentiation of this we will do. So what will be the final answer? 2yz. Okay, first differentiation will be 2xy, and then x will vanish, 2yz, double differentiation is there, and then the second differentiation of this first is 3ayz squared, and the second differentiation will be 2 plus 6ayz, 6ayz plus 0. This must be 0 for Laplace equation. So from here we will get what we will get. We will simply get a is equals to, what is the value of a? Just tell me. Minus 1 by 3. Okay, so this is the correct answer. Next we will discuss on next class. There are actually 2 gate related questions also. Let me just introduce, both are easy ones. This is basically del cross A. What will be the unit of this? Basically, this is having units of del upon del x or del upon del y, you know. So this is having units of basically 1 upon dimension of length. So this is having 1 upon meter, and h we already know 1 upon meter, and h we already know ampere per meter. So this will be ampere per meter square. Okay, and coming to the next, I have a few more questions, but I'm not able to do due to time restrictions. Now coming to the next, this is again very simple, very similar to the last question we have done on the 10th question, very similar to that what will be the value of C. In the 10th questions, the value of A was asked, that suppose this scalar function satisfy the Laplace equation, then what will be the value of A? Here it is given that this phi is electrostatic potential. Okay, they have just modified the language. What they have just done, that this is a electrostatic potential, and we know electrostatic potential follows this equation. This is Laplace equation, and they have mentioned source free regions. So that's why we will take this is equal to 0. So this will be equal to 0. So we will just need to calculate this. The del square phi will be 0. Del square phi will be 0. And then you will get what will be the value of C. Okay. Similar to the 10th question we have already done. Okay. That's enough for now. Bye. See you in the next lecture or next doubt session.